Now before I talk to you about how pulleys work, I want to talk about how lifting objects manually works on your body. Now I have a 45-pound weight here, and if I lift the weight with my legs, you can see I can still pick it up. But to my feet and my legs, I have to lift up the 45-pound weight as well as the weight of my body, making this 45-pound weight now feel like 195 pounds in total. But if I use the pulley above me and run the line through it, I can redirect the forces. Instead of having to lift up, I can pull the rope down, meaning I don't have to lift the weight of my body, making lifting it up much easier because now I don't have to fight gravity as much to pick up the weight. And see, now I can use my body as a counterweight to help pick up the weight. Now, in my pulley system, I have two pulleys. One at the top, one at the bottom that's holding up the weight, and then an anchor point up here. Now what this does is it now redirects the forces, the tension forces on the ropes, to two ropes, effectively dividing the weight of the weight by two. So now when I pull, I'm only feeling half of the weight pulling back up against the rope on my side, meaning I have a mechanical advantage of two. But because of this, I also now have to pull twice as far to get the weight to move the distance I want. Now, lifting my weight, I have these special pulleys called block and tackles, which are basically two pulleys, two pulley wheels held in one casing. So now if we count how many ropes I have in tension, I have 1, 2, 3, 4 separate ropes in tension, meaning I have 4 ropes sharing the same load. That means I only feel a fourth of the weight, but I have to pull 4 times the distance to get to the distance I want. And so if I pull, you can see it's much easier for me to do this, but I have to pull so much longer to get the weight up higher. Now, this type of a pulley system I have put together is what's called a compound pulley system. It is because I have multiple different systems stacked on top of each other to make a full compound system. Now, just like last time, this ratio is still a 4-to-1 mechanical advantage because I have 1, 2, 3, 4 ropes in tension holding up the weight. So just like last time, I have to pull 4 times the distance, but I experience a fourth of the weight. Now that we've talked about the real life examples, let's talk about the physics behind pulleys. So if I put my pulley here and my mass down here below it, then tie the string through the pulley and then out, if I pull this side of the string backwards, then the force on the other side of the pulley is directed upwards towards the pulley. Doing this doesn't add any forces to it because you're not adding any more ropes to the mass side. So 10 pounds on this side is 10 pounds on this side. But if we change it up, if we had a pulley here, a pulley below it that's connected to our mass, then have a hard stop for the rope, can bring the rope through the first pulley, up to the second, then back down. So now, when I pull on the first rope, now both of these ropes are experiencing the same tension as the first rope. And so they both pull upwards. So this side of the rope pulls towards the pulley, and this side of the rope pulls towards the hard stop. Meaning, if I put 10 pounds of force on this rope, then I get 10 pounds of force on both of these ropes. So 10, and then 10 makes 20 pounds lifting upwards on our weight. Meaning, I have 2 times mechanical advantage. But in that sacrifice, I now have to pull this side of the rope twice as far. Now this is exactly how the block and tackle pulleys work, except they're just more compact. So you can think of the block and tackle pulleys as being 2 pulleys right next to each other. So if I have these bottom 2 pulleys connected to our weight, one end of the rope connected to a hard stop, I can go through pulley 4, up to 3, down to 2, up to 1, and then back out. So now if I pull down on the input pulley, I have 1 rope, 2 ropes, 3 ropes, and 4 ropes, all pulling upwards. With the same 10 pounds of force I put on this rope, now I have 40 pounds of pulling upwards force on the weight, giving our mechanical advantage a 4-to-1. But now I have to pull the input rope 4 times the distance. We can now apply these same physics to our compound pulley system. So if I draw out the 3 pulleys, the 2 attachment points, and our weight, we can now draw the lines for the rope. So we have our input rope that goes down to our first pulley, and then the attachment rope from the first pulley to the second pulley to the second attachment point. So now this is where the forces change, because the forces that act on this system are different from traditional pulley systems. So if I input 10 pounds on the input rope, I get 10 pounds and then another 10 pounds on these 2 acting ropes on the second pulley. So now this second pulley has a tension pulling upwards of 20 pounds. So that means this rope's tension is now 20 pounds in both directions, making this lift up the weight with 40 pounds of force, multiplying our input force by 4, giving us a 4-to-1 mechanical advantage. Now again, this also means we have to pull the input rope 4 times as far to lift up our weight as far as we want, but we get 4 times the amount of input force that we put in. Alright, now that we made it to the end of the video on these simple machines, I would like to say thank you to everyone for watching, and I apologize for the lower quality content. This is my first time on camera being recorded like this, and hopefully within the next coming weeks these videos get better and better, and I would like to apologize for the starting video not being the greatest. But again, thank you to everyone for watching, and please tune in next week for another video.